Well, hi, good morning. Welcome to my shop. First, I apologize for posting such a long video. The last video I posted was almost 2 hours long on these guys, so kind of got a little out of hand there, but hopefully you can fast forward and other things to get through a video like that. Or watch the whole thing. Okay, so where am I at with these? I think they're fixed up and ready to be calibrated. I'm really interested in how this is going to come out. I've got the two units sitting here. They're both switched on. They're both plugged into the oh so wonderful power bar here. And I was in the process of checking case voltages and that. Even though chances of getting a serious shock from these case voltages is very low, getting a small shock is still quite possible. And I'm still trying to decide what I should do with it ultimately. So let's check the ground potential now, or the potential of this case to a real ground and see if I can see something. Explain me this. There we are. 155 volts. I'm on the 200 volt scale AC. No doubt about it. This meter tells me 155. This meter, let's just, in a world where everything should be doubted, let's just see if another meter comes up with the same number. I'd be stunned if it didn't. So these meters are trying to read the RMS equivalent. They're trying to display the RMS equivalent of the peak-to-peak voltage you're measuring in AC. All these meters. If a meter isn't reading RMS, it should have a big message on it that it doesn't read RMS. So here we go. AC volts. Mr. Meter, what do you say? Get my arm in front of it. The mystery deepens. 131. And what's the other cabinet? Saw 151 there for a moment. 36. So, that's the kind of voltage I would expect to find on a case that's being energized through capacitance from the power line. In this case, I believe through the power transformer, interwinding capacitances. Kind of always expected to be somewhere between 0 and 120, probably in the 30, 40, 50, 60, 70 range all the time. I go back to the other meter. 130. Now it's plugged into an outlet, and the voltage in the outlet is going to be 125 or something like that. So where's the extra 5 come from? Why? Well, this just gets more and more. I'm starting to think that what I'm seeing here is, since I'm reading a circuit basically through a capacitor of some sort, that the capacitance of the meter is starting to do voltage division stuff. Instead of a voltage divider based on 2 resistors, you could base it on 2 capacitors in some circumstances. Obviously not with DC, but with AC like we're measuring now. Okay, here we go. But clearly there is something different about these 2 meters. Gee, if I had a VTVM handy, I would use that too. Have I got another meter? Have I got something that's radically different from these two? I mean, these are both digital meters here. What have I got that's radically different? I got my little, totally inaccurate little pocket meter. That's just not going to do it. I don't think I really have another alternative way of measuring the voltage here. My scope. Yeah. Let's try it. Now, I'm thinking about using the scope's fine. That's perfect. Great idea. I'm going to use a very simple lead on the scope, not the let's call it the official scope lead. So this is a very simple lead. Yikes. 5 volts per division. That's the best I can do. I'm gonna have to put in the other test lead. Okay, we can't do it with 5 volts per division, that's for sure. And the other one is here. So if you're familiar with tectonic scopes, you know what's going on when I plug this in. But if you're not familiar with a tectonic scope, if you look very carefully at the little lit part there, just above my finger, where the value on this control is lit, so I can tell it's 5 volts. Watch what happens when I put this in. Watch what happens to that lit spot. Try not to get my hand in front of it. There, see it jump? Yeah, actually plugging this in actually does that. It changes the range of the meter. So now we got 50 volts per division, which is excellent for what I'm doing. And we'll just put this right in the middle. We're going to see a peak-to-peak voltage here. First, let's look at the voltage coming out of the outlet. Straight out of the outlet here. Doing this, wait a minute, because this is grounded. Too much danger involved in doing that. I'm not going to do that. Not going to do that. I can probably get it right, but if I don't, that's bad news. So I could. Why would I? And why would I? But I could. I can read the voltage out of here much more safely. This is on an isolation transformer. Let's do that. You have much better control over that outlet, whose power is shut off right now too. Good idea. And we'll just compare what the scope shows with what the meters read. So the scope will show us without a doubt what the voltage is here. Okay, I have to trust myself now that I did all this right and there is no ground to worry about. Boom! I don't have the switches on right now. Let's put this here. This guy is a little bit dangerous here. It's even more dangerous if I do that. Dangerous in the sense that this clip can move, a clip can pop off. I mean, it's plugged right in. Plugged in. It's going to have 120 volts with at least 10 amps of capability behind it. I also do not want it touching these cabinets. Oh, I do not want it touching itself. It's still off, so we're okay. You know what? That's going to be good like that. As long as I don't catch it in some leads or something. This meter. Hey, let's do it like this. So I don't have to fool around with leads at all. I will clip here, go here. It's going to be a lot of leads on the table, but that's okay. Just a moment. Oh, careful there. Wrong end. AC 200. Don't have to worry about grounds or anything like that when I'm using these isolated meters. That's one of the big advantages of using them. Okay, so everybody should be saying the same thing all the time. And then I can actually take and test the same thing with these meters too, if I really want to. But first, we're comparing these meters against what the scope is telling us. I have little or no control over the actual voltage. It's going to be 120 volts or so. Is there any reason why I shouldn't hit the power here? Let's just think for a minute. There is no reason. Hit upon the power. There we are. Ooh, such excitement. Okay, we'll let everything settle down here. Unfortunately, this is really filling the screen completely. Pretty much in the center. 1, 2, 3. and a little bit. So we're going to measure this very accurately in a moment. I just wanted to make sure it's roughly in the right range. So that would be 150, 165, something like that. I happen to know what it is supposed to be exactly. This guy went to sleep on us. So in terms of these two agreeing, they're not exactly right. They both present the value with a 0.1 precision, but it looks like their accuracy is not quite there. Could it be test leads or something like that? Doubt it very much. He says, as this one changed when I wiggled it. The reason I say I doubt it very much is a little bit of resistance in a test lead shouldn't cause these readings. This one does seem a little loose. Feels loose. Feels like I could pull it right out. But again, I don't think it's going to interfere with the reading too much. How about this end? Anybody? They're all kind of wiggling around a little bit, aren't they? Just looking for a gross problem here before I start. Good. Keep your fingers away from that now. So if we look at the scope again and we really make a careful measurement here of what the peak-to-peak voltage is. So I'm putting this so it lines up on the bottom and we can count exactly 1, 2, 3, 4, 5, 6, 7. It's exactly 7 divisions peak-to-peak. Oh no, I'm going to have to make calculations here. Give me a piece of paper. Somebody, anybody. Here we are. Here we are. Here we are. Here we are. Okay, and put a pencil with some lead on the end. Okay, there we go. By the way, one of the most amazing materials that's being experimented with these days is graphene. You want to see some? There it is, right there. That's right. That's graphene. Look at that. Twice as much graphene on my paper now. Isn't that something? Okay. If you don't know what I'm talking about, read up on graphene. And while I'm talking about things you should do, if you like videos that make you, that provide you with a shockingly alternate, scientifically view of accepted facts, then watch videos done, at least they're called Sky Scholar. It's a doctor, I can't think of his last name, the guy's a scientist, it's clearly a scientific level presentation, a completely alternate view of what the sun is, and it's really interesting. A lot of 10, 15 minute, fairly short, single or double topic videos, well worth looking at. Sky Scholar. Let the top of your head blow off when you listen to this guy. Okay, back to the graphene display. So we're looking at 7 times 50 volts. So, and then we want to divide that by root mean square. By. I'm not sure I can remember. Let's just keep working away at this. So that's 350 volts peak to peak. So it's is it not 0.707 times the peak to peak or the peak? Well, we'll know when we do the calculation. So I need to calculate this. Okay, hang on. I'm just going to use my oh so powerful computer here, provided I can do it. Just bear with me a second here. Okay, so we're going to divide. We're going to multiply 350, that's the peak-to-peak voltage, times 0.707 by my memory from 30 years ago. We get 247, divide that by 2, because obviously that can't be it. Divided by 2, 123.7. So, according to the scope, we have an RMS voltage of 123.7 if 0.707 is the right value. That's right, you'll be all healthy again if you just take the medicine I'm giving you, as long as this is the right medicine to make you healthy again. Fantastic. So, all these guys are basically in agreement. No surprise in any of this. No surprise at all. what am I doing next? I kind of lost track of the whole reason for this. Oh, that's right, I remember now, because I was reading a crazy voltage here to ground. So now I want to look at the same crazy voltage to ground on the scope. So I want to read from the chassis to ground. So I just put the test lead. I think I just put the test lead on here and leave the ground disconnected. I think that'll do it. But voltage off here before I fry myself. Voltage off. Voltage off. Okay, so now we're going to look at the mystery voltage, we think. Anyway, watching the scope here. It should be right off the scale, and it is off the scale. It is. So the scope is seeing the same effect. So now I really can't tell you how many squares it is. Let's just bring this down a little bit. Oop, wrong control. So it'd be, I think it's 8 squares for the screen, plus looks like 2 more. 8, 10 times 50. 500 volts peak to peak. Boy, that sounds scary, doesn't it? Really? So 500 volts peak to peak would be 250 peak times 0.707. Take 70% of 250. That's way high. That's 160 something. What did I do here? What's happening here? Where am I at with all this? So the question in my mind is, and I don't think I've actually been clear the whole time I've been doing this, is how do you plug something into 120 volts and then begin reading 150 RMS with a meter like this? Weird and wonderful wave shapes in here that are throwing off the meters. I'm not sure that's really possible. Extraneous frequencies, where would that come from? I just got no answer for this. What was the suggestion last time around I found this voltage? And what did I find it on? Is this the same? It's the same meter, I think. Some kind of DC leak. Hey, I've got the scope on AC here. Let me just brighten this up so you can see it. If I put it on DC, does it go flying away? No, it doesn't go anywhere. No, there's no frightening DC voltage on there. I don't know the answer to this question. I'm just doing this out of interest. I'm just curious about how this can be, because from everything I know, it can't be. You can't get this higher reading. But nevertheless, we do. So I'm gonna have to leave it at that again. I can't get to an answer here. Just put it on the list of all the things that I have seen and done that don't make sense to me. But nevertheless, I have seen them, I have done them. Okay, let's get to doing what. This is going to be another 2-hour video at the rate I'm going here. I don't want that to happen. Okay, once again, reminding myself both these units are switched on. No, they are not. Yes, they are. Oh yeah, definitely. Okay. Calibration. So the very first step in calibration is simply to make sure the pointer sits on 0. It's not sitting on 0 now when the units are switched off. So let's switch them off. and we'll adjust the mechanical balance in the meter itself. Just making sure all the voltage is drained out. This one's really pretty close. Yeah, pretty close is right. Okay, so I'm trying to hit dead on. Okay, so I'm not adjusting that one. This guy, he's not so good. Now, first of all, we tap it. And I'm going to adjust it. The part I'm adjusting here is this little plastic screw down there. It's not going to go up all the way. Gotta ask yourself, why wouldn't this make it all the way up to 0? Parallax. A little bit of parallax in the camera right now. There's no parallax there. So it's not quite to 0. Kind of off to a bad start. If it won't 0 mechanically, got to go all the way around with the screw. You can see the part that's pulling the spring. There's a I'm watching now to see if the pointer is really moving free. Yeah, seems to be. I'm just going to put that right at the very, very top. That's as far up as I can pull that pointer. I was thinking about this. What would cause these meters to become permanently inaccurate? Is there something? I was thinking about, well, what if I just can't force the calibration? What would that be? Wouldn't I be going and looking for resistors? Oh, quite likely. Well, what about the movement itself? Could the meter movement itself get weak? And then I thought about the spring. Well, you know, the spring might have a life to it. Daystrom. 1480 Dundas Highway East, Cooksville, Ontario. 200 microamps. So the guy also come from Cooksville. Cooksville. I'm not sure where Cooksville is. Ideal Precision Meter Company Incorporated. Okay. So now the next step, and we'll start with this guy here. The next step, camera doesn't like being so low. That's what this is. This is a counterweight to help the camera ride low. Have some more weight. There we go. Okay. Next step. After doing the mechanical alignment is turn the instrument on, set the function switch to DC plus, check operation of 0, adjust control. Turn the units on, set them to DC plus. Check operation of 0, adjust control. Turning this control should move the meter pointer partway upscale. Set the pointer to 0 at the left side of the scale and check for 0 positioning when function switch is changed to DC minus. It should be possible to obtain a 0 adjust control position that will permit the meter movement pointer to remain stationary when switching through from DC plus to DC minus. If there is an appreciable zero shift of more than 2 divisions on the scale, it should be regarded merely as an indication that additional aging of the 12AU7 tube is required. The aging can be obtained by leaving the instrument turned on for a period of 48 hours or more. So the 12AU7 is used in an interesting way in this meter. The meter movement is actually connected between the 2 cathodes of the 12AU7. And it's a variation in voltage, or difference in voltage between the 2 cathodes, that drives this meter up and down. Well, I'm going to assume this thing is well aged. Zero adjust. Okay, so checking the zero adjust on each meter. Do this. Have a long camera. Up and down, no problem. And I'll put it right on the zero. Check minus. There's no appreciable movement there. Good. Okay, how about this guy? Zero adjust. Oh yeah. I kind of flung it there. Lots of range on the zero adjust. Okay, so it's right on zero. Flip it to minus. Oh, okay. Flip it to plus. Minus. Get out of here. There can't be a spot where this all balances out, is there? We're just up above the zero, but there's no movement in the, just below the zero, there's no movement in the pointer when I switch. Oh, you know why that is? Because I can't mechanically bring it up. So it's actually on the correct zero for the meter, the way it operates. This is where zero is. That's right, Jim. That's where zero is. Okay. Okay. Let's keep going. We did that. DC calibration. Insert the test lead phone plug. Set the function switch to DC plus. Range switch to 1.5 and probe to DC. They want you to use the probe on this one. Connect the probe and common test leads to the flashlight battery and adjust DC calibrate control so the meter pointer falls directly over the very small red dot on the meter face. Okay, what's it saying here? It says connect the probe and common test leads to the flashlight battery, not to a flashlight battery, but to the flashlight battery. The red dot. Okay, so red dot. Let me get it on the close-up camera here because you'll never see it with the far camera. The red dot we are aiming for is right here. Right there. So it's saying hook up a 1.5 volt battery. You actually use the one that's in the machine up here, but it's not in there right now. The battery that drives the ohm meter readings. Utilize that battery and set this meter to read there. Now, could they have done something special with the battery voltage in here so somehow it's become standard? I can't believe that for a minute. I think I have much better alternatives here. See, the problem in a regular household shop like mine back then is you've got no voltage standards to work from, other than, say, a brand new battery, or maybe if you were lucky you had a mercury battery somewhere. That would provide you a really well-known voltage. But otherwise, you can even see in my shop with these very modern digital meters, there's still a small variation on them. But I don't have to follow their procedure. I can do this all by my little lonesome here. You can still use a battery if I want. So it is recommending you do this on the 1.5 volt scale. That's probably because you're using a 1.5 volt battery. And for my voltage source, I'm going to use a power supply over here that I can vary. We'll do this hook up all the meters together thing again. I kind of like that. I'll watch all the meters go. Let me switch you to the longer range view here. These are the test leads from these 2 meters. Get these out of here. It's too much for my eye to follow. We want to bring a lead down from the power supply. By the way, we're still monitoring CV here. So the sun is doing some strange things. I shouldn't say strange things. The sun is producing a large amount of solar spray. I call it that. Solar spray. And it's impacting the Earth, magnetosphere, and other things. Sound like I know what I'm talking about, eh? There's some DC voltage on the end of these now. 10 volts according to that meter. So we will now find out according to these meters. At least the one that's still awake. No, neither of them are awake. They're both asleep. DC. DC. Just a hair under 10 volts. They're giving us the same reading. Highly reliable. Now, we can find out what these meters are saying. Of course, I'm on the 10 volt scale now. So let's crank this down until we see the 1.5. We'll try to follow this. See, here's the problem. You know, these 1.5 volt batteries, they aren't really 1.5 volts. When they're new, they're more like 1.6. So if you're going to calibrate March 2016, if you're going to calibrate against one of these, then without anybody actually saying it anywhere, it's actually 1.6 volts. It's probably why the dot is not at the 1.5 mark. Well, let's go with the meters. Let's just do this and do it here. I might end up. Can we even get to 1.5? I might not be able to. Oh yeah. Yeah, I don't know how accurate I can set this. I mean, as long as we know what the voltage is, it doesn't have to be exactly 1.5. A little under might be better. Of course, I'm aiming for that red dot, aren't I? That's because it's not 1.5 on the battery. Yeah, I should pay attention to what I say. So set it anywhere at all. Believe it. 1.5. Very close. Very close 1.5. We couldn't even see the other meter all that time. Yeah, they aren't in disagreement. So we're now to put in the test lead. This is where we're going to start discovering about the test probe. Where's the probe gone? Oh, once again. Okay, because I can't spot the other one at the moment. Let's use the inappropriate lead here. So this is the one without the mega ohm resistor or anything at all. It's just 2 probes at the end here. And we want to read, I think I better assume the negative lead coming from that little power supply. No, it's not grounded, but I'm going to assume it is. And be smart about this. Try to be smart about it. At least look smart. That's, you know. Switch cameras now. Sorry for the bad angle there. That's a little better. Now let me get this lined up here. So it's not exactly a 1.5. And these other meters are reading actually 1.47. So we look at this meter, 1.47. So it's 246. Wow. Wow, is that ever accurate? Holy smokes. I'm really, really impressed. Okay, let's see how impressive the other one is. I'm really impressed. Before we do that, let me reduce the voltage. I'll aim. What I'll do is I'll make this pointer line up, let's say, on the 7 here, and then we'll see what the other meters say about that. Let's try that approach. Or somewhere in the range of the 7, as best I can get it there. It doesn't want to stop right on 7. Okay, so on the Heathkit meter we're looking at, that's basically 6.6, just under. 6.6, just under. And if we look back now at our standard meters, point 0.66, just under. 0.66, watch, fantastic. That's fantastic. Let's go up to a different range. We'll go through the ranges here. So, crank up the voltage. Put this about mid. You know, that's where I would do most of my readings. I'm going to put this on what I think is so what scale are we on? We're on the 5-volt scale. So on the 5-volt scale, we're now 3. Well, let me look at the screen with you. 3 point. That's 30 point. That's 31. 31 volts. Oh yeah, you know, I could have cheated and just looked over at the other meters. 31 volts. 3.1 volts. That's right, yeah, 3.1 volts. Excellent. Other than me being unable to read the scales here. 3.1 volts, that's fantastic. But most of my readings are done on much higher settings. So we'll try 15. Do we get 3.1 volts on 15 scale? Without changing the voltage here. Well, yeah. See if I just pull this way a little bit. There we are. Perfect. Actually, that is without parallax now. 3.1. This is great. I didn't realize just how accurate this meter could be. So I'm going to crank up the supply voltage here. Get us a little bit up in the middle. Okay, so now we are on the 50 volt range. So we've set it to 22 volts. 22 volts, and we spy upon the other meters. 22.4. That guy's gone a little too high. 22.2. This is fantastic. I can't believe it. Let's go on another scale up. I'm going to run out of voltage range on my supply here. I think this guy, how high does he go? Well, we're going to find out. So that was me crossing a safety limit on this meter. 53.8, and what do we get on here? On here we get, okay, a little parallax there. Let me just straighten it up there. Well, 53.8. I mean, it's wow. Very, very accurate. Okay, I think we can go one more scale. So we're on the 500 volt scale. And this is a scale I would use. I'm just gonna, my power supply doesn't have much more left. It's got nothing left. And the top of the power supply. So 53.9 volts, read on this scale, down at the end here. So that would be 51 volts. I would make that out to be. So not quite so accurate, but look, it's at the end of the scale. I mean, you want these things up more in the middle, not at the ends. I really don't want to bother going any higher with it. Whoops. Now, pinning the needle is not a particularly bad thing to do on these meters. Because of the limits that are built into the meter, the way they drive the meter movement. But it does warn that if you do, for instance, have this on a sensitive scale and then stick it on a high voltage, look at those cracked and dry hands. Oh my God. If you do that, the risk is slamming the pointer against the stop and having the pointer bend. Because there's no bend in the pointer. It looks beautifully straight to me. Great. Okay, let's go to the other meter now, and we'll check this one for accuracy. I won't just keep going today until I'm blue in the face. Okay, let's get this guy lined up here. Now, what am I going to do because he's off zero? There's not a lot I can do about that, so I'm going to move the test lead over. Anybody hear that snap? I'm sorry I didn't get that on camera. Did you hear the snap? Bring in this test lead. I'm beginning to plug it in there. While I've got I got my power supply cranked out on this. So of course, as I started putting it in, I shorted this briefly. So the rule is you can't have these test leads hooked up here, dummy. I mean, that's square one, Jim. Okay, we shouldn't get any big sparks this time. See, in a world where you need to think of everything, we're human beings and we can't do it. We can't think of everything. Okay, so I'm going to crank down the voltage here. You'll have to trust me on this. First I'm going to set the voltage to 1.5 and we'll just see if it doesn't come up on 1.5 here. I'm using the reliable digital meters to measure the 1.5 as soon as I change the scale there. Okay, 1.5. Oop. Just give me a sec here. 1 point. It's really tricky to get it right on. Okay, 1 point. Hey, there we go. 1.5. That's not too bad, eh? 1.52 is what that actually said there, in case you're wondering. Oh, okay. Now, what do I have this hooked up to? Nothing. And we'll now connect the meter. Goes right off scale. So we're 1.52. And on there, I would read that as 1.54 or even 1.55. Let's take it down to 0.8 volts. If I can do it. Huh, I like that, eh? Okay. So it says 0.8 plus on that meter. And on the other guys, what's going on with this one today? It's getting some kind of weird reflection that I can't seem to escape here. Too much light in the shop today. But you can see what it is, 0.75, and the other one is 0.749. So 0.75, and this guy's reading 0.8. Right now it's just a hair under 0.8, so a little off. So it's reading a little high, even though the 0 is a little low. Is the 0 still the 0? Yeah, it's still a little low. A little hard to see at the big camera. Okay, so that's a 1.5 volt scale. 5 volt scale, and we'll hit that with, let's say, how about around 2 volts, 2.25 volts. So on the meter, on the 5 volt scale, .3 volts, and the actual voltage is 2.2, 2.3, 2.5, 3, yeah, 2.3 on here. It's reading a little bit high again. It's interesting that the 0 is low, but the readings are a little high. That sort of makes me think there's linearity problems in here. Next guy is a 15 volt scale. We'll shoot for around 7 volts or so. Turn the right control. Okay, that's the I'm gonna go away warning. On that meter. So on this meter we're reading, just make sure, yeah, that's very little parallax there, just a fraction over 7. On the other meters, 6.7. So we're reading a little high still. It's always reading a little high. Hints at something, I guess. Now, how accurate do I need these readings to be anyway, really, in reality? 50 volt scale. Let's see where we get to here. 25 on this meter. Just reading proportionately higher as you go up the scale, I guess. Is that what it's doing? Maybe not. This proportion is the same. The numbers are different. So what's this actually? Reading at 25 right on the money, and it's 23 on these. Still reading high. 150 volt scale. These are the scales I would use all the time. That's the high voltage warning from the 1 meter. I just cranked it up all the way. It's 53 on the digital meters. And on this guy, on the 150 scale, 50, 55, 55, 55. About 2 volts. It's certainly within reasonable accuracy for use. I don't think there's any doubt about that. You watch me, I don't make super precise measurements normally. So it's actually holding up really well. Now there are some calibration adjustments. There's basically 3 of them. They're all in the front of this meter. DC calibration, AC calibration, AC balance. So that's where we're heading. What about doing the same thing on the AC scale? You know, I'm not going to bother with the AC scale. I don't think I'm for now. Let's just say for now. Okay, what's next on the menu here? So we've done the zeroing using the zero adjust. Now we do DC calibrate. Put the test plug in. Function switch DC plus. Range switch 1.5. Probe. Oh, I didn't do this with the probe. Son of a gun. You know what? We got to stop. I got to back up. I got to find that probe. Where did I put it? It's got to be here in my shop, somewhere right here. It can't be very far. If I were a probe, where would I go? I would hang from the wall here. Presto. Now it may not have been clear in the last video when I clipped a clip lead here. it's actually catching the shield wires, the few remaining shield wires right in here, and that's why I'm getting a ground here. I was not clipping it on the conductor. It may have looked that way. That's where I was picking up the ground. I have to do the same thing again, and then I'll repair all this properly. That looks really bad. So I did all those readings without using the proper test lead, supposedly. Let's try them again then. Okay, we'll put this in this meter. I have to, oh my gosh, there's more solder strikes on here. Somebody was operating with a messy bench. I think that might be the case. Clip lead for ground. We can do it right off the case here, I think. Okay, I'm going to pick one of these over here to put the ground on. Let's elevate the camera. Oh, whoa, whoa, whoa. Hey, man. There we go. So this is this meter. And this will be the other meter. Set to DC. Everybody's hooked up now. I'm not getting a reading over here. DC plus, 150 volt scale, lead. This ground thing didn't do the trick. You gotta troubleshoot your troubleshooting. There we are. 53, 150 scale, 55, 56 on this one. This guy 150 scale. This one's 48. If I take it off the DC switch, watch that meter. Now it reads correct. So this is falling off. So I just nowhere am I reading about this 1 mega ohm resistor not throwing off the readings. I don't get it. Okay, so the resistor is switched in now. I understand the idea. The idea is to actually, you know what it says in the manual? It says right in the manual what the idea of this is, and I was kind of surprised. It's not what I thought, contrary to what I was in the verge of saying. Let me read it to you, what it says here, if I can find it quickly. Very quickly. You know, I'm not going to find it. Okay, I won't read it. I will tell you what it said. It said the purpose of the resistor is to allow you to make DC measurements while not influencing the AC circuit. That is what it said. And I'm not going to find out where it says that. There's also some other stuff about a buck-out voltage in here. There's some strange stuff written in here. I can't find it. But that's what it said it did. It's to allow you to make DC measurements without disturbing the AC voltages. And this buck-out thing is to remove a residual reading on AC that will sit when there's no voltage applied. The meter will read upscale ever so slightly. And so this bucking thing is done to eliminate that. Well, I guess, you know, like with any electronic machine, there's lots of challenges here. So I'm still trying to find that little section to read to you, but I can't. So, oddly enough, I've heard everything other than that for that resistor. Mostly I've heard you're putting the 1 mega ohm resistor in the pointer, like in the inside the thing here, to reduce the amount of current that's flowing into the meter and down the test lead, to more isolate the test lead in the equipment you're testing. Yeah, I'm just muttering, aren't I? Okay, so we'll do the AC balance adjustment on these meters. First I want to kill that power supply over yonder here. Pull this out. Pull it out of here too. Okay. So the idea of AC balance is making this pointer not move when you're switching it like this. I don't think it's moving much already. Well, that's good. I mean, there's no reason to think this meter isn't necessarily all messed up. The autofocus is going to do the trick. There we are. Okay, so I'm going to switch between the different ranges and watch that pointer. So this is AC, DC minus. There's really nothing much there, is there? What happens if we turn this control though? I'm just curious. Okay, we're in. Turn. Knocked it down, so it moves it. Okay, let's see. Shouldn't I be on 0 right now? That's hardly moving. I mean, how much better can you expect it to be? Now we do AC calibration by putting a known AC voltage on here and then calibrating, doing the AC calibration here against it. So we need a known voltage. Sounds like another sounds like I gotta plug all this back in again. Power's off. This around. We're supposed to plug back in the test lead. I'm still going to use this one. This will be the ground from it. It's going on to an isolation transformer. There is no earth, no polarity concern. As long as I know what I'm doing. Set the probe to AC. It takes the resistor out of the circuit. Wait for focus. Focus, focus. We're all set now. I know I need another meter on here. Break all this down here. Okay, so this is this meter. We'll use that one. This guy out, or we have to listen to him complain. This is set to 200 DC. That's no good. You want it on 200 AC. And this guy should be set to 150 AC. We're all set. Okay, we'll apply the voltage. It's 124 point nothing. And we'll take a look on here. And we'll see what we see. So again, it's where is it? 124.1. On here, I would read that as 138. Wow. That's way out. Let's see if this will. Oh yeah. Hot diggity. Oh, you can't see anything. Just the back of my hand. Hot diggity dog. This guy's really a big adjuster. So we want to hit. My meter went to sleep. 124. We want to put this on 124. Anybody home? There we are. So that's great. And the last thing to do on this meter would be, let me just take a peek now and see if I can, maybe I should switch over to the other meter. Yeah, why don't I do that? I'll switch over to the other meter. Power off right away, power off. Other meter, take this out. Set this to AC, 50 volt scale. That's right. In you go. Meters. It floated up off 0. I'm going to guess that's just from extraneous signals. We're all set. 150 scale. Everybody happy? Everything safe? Here we go. Voltage applied. Oh, what happened there? Oh, I know what. I don't have the ground on. I got the ground on the wrong meter. Power off. That's why it's reading up scale also. Put this here. Down it goes. All the way to 0. Power on. This is way off. Okay, it's way off scale. So we're going to immediately go after this calibration. Oh, it's in the back. Oh yeah, so this is a different deal. There's nothing in the front. I got to come at it from the back. And which one's which? I hope it says back there. Can we turn this all this way? We've got 120 volts on those prongs there. That's all my eyes are on. Oh, this is going to fall over here. Okay, hold on. Power off, power off, power off before. No reason to have the power on during that. Deal. Power off to here. Still on the meters. How am I going to do this here? Oh. See, I was lining up to make adjustments on the wrong adjusters. Son of a gun. Okay, so this meter's got to go away because it's just in the way right now. Put it here. This guy's got to come over here. So there's 2 adjustments here on the front. Oh, I see what's going on. Okay, so there's 2 adjustments kind of on the front, and then there's 3 more further back, but they're lined up, so when you look, you think you're seeing the same ones. Does that make any sense to anybody? So we're going to have to put this kind of like this. And I'm going to want to see the front of the meter while I'm making the adjustment. I can use the camera for that. Something like that, eh? Wouldn't you think? Now, so we want to make sure the high voltage is applied to both meters. This one. Make sure this one is set on AC 150. Yes. Now, figure out which one of the 3 things at the back there I've got to turn. Maybe they're labeled. Hopefully they're labeled. They are labeled in there. Oops. AC calibration on the left. Is that the only words there? Yeah, I think so. AC calibration there, and this one over here is AC balance. And that leaves DC calibration in the middle. So again, DC in the middle, AC calibration to the left, AC balance, which is the one we're after, to the right. AC balance to the right. Sorry about all this monkeying around here. Come on, you can refocus. There we go. So now the idea is to get this thing to read the correct voltage. The correct voltage is going to be around 123, I think. I think we're all set. I'm just doing the safety thing here. I'm sure we got everything hooked up. Yep. Voltage applied. Right over. And we want to crank that back to 123.7. That's what it is right now. Yeah, so I'm going to do a AC calibration adjustment, and then we'll do the balance. I just want to bring this roughly into its proper area setting here. Hold still, meter, don't go anywhere. There we are. 123, just roughly. Good. So what we really want to do is AC balance. Power off. Pull the plug out. Didn't I do that already? I did this already, didn't I? Let's pull the plug out. Come on out of here. Okay. AC balance adjustment. I couldn't have done it. It's from the back here. AC balance. Now this is from switching the range control from AC to DC and back. Okay, here we are. Ready? Here we go. Switching. This meter, is this meter on? It must be on. Why would it not be on? Sure it's on. What am I talking about? I'm just so surprised that it actually appears to be perfectly balanced. Let's try it again. Not quite, eh? Okay. Balance control has almost no effect. What the heck is he doing here? So that's AC. I can push it up towards the 0 with this control. Now if I flip it over to DC or DC and I adjust this, since I'm much more interested in this meter on DC, no, it's not doing anything. Okay, we'll go back to AC. And we'll just kind of bring it up as close to the 0 as we can. I think that's probably the most effective thing. There's not much going on there. DC calibration. So we'll continue with this same meter now. We'll just flip on to the DC calibration and we'll go back to the other one after. Calibration of the DC. Insert the test lead, set it to DC plus 1.5. Connect probe, common test leads, flashlight battery. Small red dot. Wait a minute. We kind of did that. I thought. Maybe not. Well, let's double check it anyway. DC calibration. So we want to apply a DC voltage now. I'm going to go back to the other supply. Power's off. AC wise, let me pull this thing right out of the outlet over here. Get it right off my bench. This that's the one thing that, boy, I put this out here, that plug, like a, basically clip leads plugged into the wall, laying on the bench. A little bit scary. Meter in. And we want to get our DC voltage, which is on the end here and amongst all these wires. There, that's a little better. So we'll continue using this meter here. So it will read the output reliably. And this meter ground lead here. Hey, what about the other meter? The other meter. There it is. Wait a minute. That's not the right connection. This is the right connection. I had too many clip leads. Too many clip leads on the bench. Okay, now we should be able to set a voltage here of some very desirable DC level. Roughly 50 volts. Roughly 50 volts. We'll get a look at the other meter here. So it's on the AC scale, reading absolutely 0. Hey, that's kind of a good thing too. We'll go to DC negative. And DC positive. There we are. The input voltage now is 50.7 volts. The reading without the resistor. This is where I can calibrate this with the resistor. I think this is what goes on here. Without the resistor, that's what it is. With the resistor, let's calibrate in this mode. DC calibration. So let's think about this. If I calibrate this meter for this pointer, I must use this, or this probe. I must use this probe. Or make up more probes. I can make up more probes. Yeah, I can make up more probes. That's where I'm going with this. Right. Nice, exciting probes. Okay, I'm into the calibration thing. So we will calibrate it with the million in there. We're shooting for 50 volts. 50 volts. 50.7. I could claim that's 50.7. Another scale. Nothing I can do about it. Now on this scale, it's reading well under 50. But see, the pointer is kind of at the extreme of the meter, and you kind of want to stay away from readings that are at the extreme. So on the appropriate scale, it's great. If I go this way, it's right over. Perfect. Perfect on this one. Now, that other meter, I'll bring the other meter up and do the DC calibration with it. Okay, power off on the supply, so I can pull this out. Put this over here. Bring this meter back up. Oh, it's been down on the floor. It feels ice cold. Okay, we can plug this in. Set this for 150 DC plus. Put this on here. down a little bit. So I will now apply the DC voltage. Here it comes. It's on there. Why isn't it showing up? So I made the ground mistake again. I moved the ground wire. Oh, wait a minute. Yeah, ground wire. Okay, we got a reading. With resistor. So I think I may have calibrated this sometime in the past and don't remember it, and did it without the resistor. Oh, calibration. DC calibration. I'm going to do it from the back here. I want to make this guy say 50.7. 50. You see the parallax error is significant, eh? 50.7. There it is. Wait a minute, I'm just looking at the right angles here. I'm looking at the camera and the... Yeah, 50.7. And I believe that's kind of the end of the road here for doing these things. Because I did the AC calibration already. Aging and final calibration. Let's see what it says. Recommended that the tubes be aged before final calibration, accomplished by keeping the instrument turned on for 2 days. Final calibration should be done the same way as initial calibration, careful calibration, AC standard, blah, blah, blah. Oh, hello, Peanut. Preferably, use a voltage near full scale on the VTVM, for instance, 140 volts or 40 volts or blah, blah, blah. So I was kind of shooting towards the middle of the scale rather than the high end, but I'm sure everything is just fine. And hey, there's a whole bunch of stuff here on the combination probe. So I'm going to read up this manual completely. And great, I think it's great. You notice I've ignored the ohm meter side of these meters. I don't really intend on using them as ohm meters at any point. There we go. Let's power off these meters. That's it. Done. So from here, I'll put the cabins back on. We'll put them away. I have another VTVM we can bring out. We can mess around with this one a little bit. Why not? Get them all done, and then I'll think about how to deal with the case voltages among them all after that. Fantastic. Thanks for watching. Hope this isn't a 1,000,000-hour video this time around. And see you tomorrow.